Hello, very good morning to all of you. I would like to present, I'm Faiz Ahmad, and I would like to present my innovation, NeToxIC. It's basically bio and recycled filler reinforced in siloxane modified base fire retardant coating. My team members are Dr. Saeed, Christopher Lambe, and Lee Yuan. The present status of this innovation is the patent is granted. We have several patents indeed because we're working since past more than 10 years. And we have filed several patents. One of the patents which is I'm talking about is a mineral-based intumescent fire retardant coating, composition and method of forming and testing the coating. This product has won several awards from around the world, including British Innovation Show, United States, Germany, Malaysia, and including MTE and ITEX. Fire retardant coating related publication, since we are working a lot since more than 10 years, we have a lot of publication in this area, but I have quoted here a few for the reference. The problem which we are facing due to the fire is the fire basically causes thousands of the precious human life every year, and according to the Fire and the Rescue Department of Malaysia, in 2018 there were 97 human deaths and 397 people were injured in the fire incident. Property loss due to fire cost more than 3 billion ringgit. And I've given a statistic of from 2011 to 2018, the number of deaths, injuries, and the loss in millions of ringgit. How useful is this product? Structural steel is extensive usage in the modern construction industry due to its unique properties of high strength and load-bearing capability. But during the incident of fire, temperature of the unprotected steel rises to the 800 degrees Celsius in less than 10 minutes, and steel loses its 50% of load-bearing capability after 550 degrees Celsius, which is a critical temperature, and it takes 45 minutes, the whole structure can collapse. Passive fire protective coatings are used to protect the steel structure and to keep the temperature of the steel structure well below the critical temperature. In addition to that, there should not be a toxic emission. It should be corrosion resistant and have a low cost. This is a typical arrangement of the coating which is coated on the structure and degradation mechanism of the coating. We have spent many years to develop the products of the intumescent coating, and now we reach to the level that we meet the Dodge standard of the safety in terms of the toxicity. And basically it includes three main ingredients. It's a carbon source, gas source, and the billowing agent based in the epoxy. The epoxy earlier had been used for the phenolic and halogen base, which we have replaced by the modified epoxy with the siloxane. It has not only reduced the toxicity but also increased the thermal stability of the coating. After making the coating, we do on this coat on the substrate. We test it on using the Bunsen burner in the lab scale according to the ASTM E119. We do the char expansion to test its density. We look at the morphology of the char. We examine the compounds available in the char due to degradation of the coating. We use the XRD, and then we confirm these compounds by using the FTIR. And we had tested these coating according to the UL94, BS S476 Part 6, Part 7 and 20 using the serums facility available in the Malaysia. This invention has a very positive impact in terms of improving the fire protection, environment, and toxicity of the coating. Earlier, the coating were using halogen and phenolic base binder system in the fire retardant coating, which produced toxic gases as upon degradation. In the current invention, new fire retardant material focus on release of the non-flammable and non-toxic gas to dilute the temperature of the flame, and then on degradation to the heat, it forms a physically insulative barrier to prevent the heat reaching to the substrate. This innovation has also utilized the waste material, which is the oyster shell powder, and a recycled material glass frit to enhance the a very positive purpose, which is the fire resistance of the coating. And number two, it has reduced the waste, impacting a very positive impact on the effect on the environment and improving the properties of the fire retardant coating. Present status of the innovation is we are at TRL level 5, and presently we are in collaboration with the Bina Paint. This is one of the local paint manufacturer company, and they are established for more than 30 years, and they are supplying paint for the industrial application. In terms of commercialization potential, the market potential, basically there are two drivers you see in terms of this. A higher awareness of saving cost and the life due to the fire damages, especially in the construction and oil and gas industry. A rising cost of the raw material for the construction, especially steel, where the application of intumescent coating is much cheaper than increasing the thickness of steel, and also logistic for the off-site application. I'm sharing here one of the statistic showing the increase of the utilization of intumescent coating in the next couple of years in the Asia Pacific market, and it's a similar trend is observed in the global market as well. We have also compared the product in terms of the performance cost with the few existing products in the market. Chotek is one of the very famous product used in the construction and the oil and gas industry. Speed height is him. In terms of the NeToxIC, our coating is suitable for the fire protection, corrosion, and the water resistant as well. Its application can be either way, by the air, spray, brush, or roller, and drying time is from 4 to 15 hours. And we can use various types of substrate which have column, hollow sections, wood, concrete, steel, and the plastic, while the other coatings have some limited application in terms of the long duration time and the higher price, while the price of the NeToxIC is about 60 ringgit per liter. And the 1 liter can cover, you see, 4 meters square if the thickness is 0.25 millimeter. For commercialization potential, we have two types of the strategy. One is the offline and the other is online. In terms of online, we have websites, we are creating the social media, we are using the social media, open for a walk-in customer as well, then the dealership program and the private contractors, which are small contractors, that will lead to the warranty given as per advice for the customer. The next we have the main contractors awarded subcontract to the subcontractors, going to the development of the scheme specified by the colors, product, and the method to work, followed by the warranty. Then we have promoting Bina Paint's product to authorize body, specifies project award to the contractors, then developing colors scheme according to the specified by the vendors. In terms of commercialization potential, UTP has already signed a joint development agreement with the Bina Paint, and we have already received the technical know-how fee in terms of commercialization. I would like to thank you for your valuable time and letting me share the information about our product. Thank you once again.